Okay, so this is a video explaining the MYP3 Unit 2 first chance test. That's Pythagoras. So question 1, right angled triangle, determine the value of P. So on this occasion, P is the longest side, the hypotenuse. We know that for a fact because it's opposite from the 90-degree angle. So P squared equals the other 2 squared and then add it up. P squared equals 9 squared plus 5 squared. P squared equals 81 plus 25. P squared equals, so that's 106. And P is the square root of 106, which we can determine on the Desmos calculator if we like. So the square root of 106 comes out to be, okay, well, 10.29563. So sensible rounding there would be 10.321 decimal place. And that was question 1. This time, the missing thing, the Q, is one of the 2 shorter sides. And we know that because we can see the 9 opposite from the 90-degree angle. So the longest side is always opposite the 90-degree angle. So I'm going to write Q squared plus 5 squared equals the longest one, 9 squared. So Q squared plus 5 squared is 25 and 9 squared is 81. Q squared plus 25 equals 81. I want to get the Q squared bit on its own, so I'm going to take away the 25 from both sides. So taking away 25 from both sides gives me Q squared equals 56. I want to know what Q is on its own, so Q is going to be the square root of 56. So I'll just punch that into Desmos. Square root of 56 equals 7.48. Let's give that on this occasion to 2 decimal places. 7.48 to 2 decimal places. Final answer. Question 3. Determine whether the triangles below are right-angled, acute, or obtuse angled. Okay, so 6 squared plus 4.5 squared, that's the 2 shortest sides in the first triangle, is equal to, let's just clear my Desmos, so 6 squared plus 4.5 squared comes to 56.25, whereas 7.5 squared, let's try that, just clear everything, 7.5 squared is also 56.25. So because Pythagoras' theorem is working on that, it must be a right-angled triangle. So that's the first one. But with the second one, so the 2 shortest ones are the 5.5 and the 2.5. So 5.5 squared plus 2.5 squared gives me, let's just Desmos it again, 5.5 squared plus 2.5 squared gives me 36.5. So if it's a right-angled triangle, then the 6.5 squared should also be 36.5. Well, let's work that out. 6.5 squared, clear that again, 6.5 squared is 42.25. So that longest side is far too long for that to be a right-angled triangle. So because that longest side is too long, it's going to make the angle bigger than a right angle. So therefore it is an obtuse angled triangle. Okay, so let's get my mathematical equipment and construct these properly. So the first one, 9 centimeters and 5 centimeters. That's quite easy because we've got the fact that it's right angled. So I'm just going to draw a 9 centimeters. And I'm going to have to move my lamp here. So question 1. Better get a darker pen than that, I think. Let's try this one. Okay, so I want to draw a 9 centimeter line. So that's 9 centimeters. Then I want a 90-degree angle. So if I can find my angle measurer somewhere on this desk. Still in the packet. There we go. 90-degree angle. So I'll line up the center of this with the place where I want to draw the angle. And 90 degrees is up there. So there's a 90-degree angle. Mark that in as 90 degrees. I want that to go up to the 5 centimeter mark. So there's the 5 centimeter mark. And then my triangle goes down to there. Rub out the bit I don't need. Or keep it in pencil if you want to show your working lines. 5 centimeters. Okay, the next one. So we've got the 9 centimeters and the 5 centimeters, and then a right angle there. Now, the way I might do this one is to turn it round and do the 5 centimeters at the bottom there. So there's 5 centimeters. And then I know there's going to be a line going straight up from that, because I know I've got a 90-degree angle there. So I'm going to draw a line that's going up at 90 degrees. But the trouble is I don't know how far it has to go, because the 9 centimeters is the long side there. But what I can do is get my compass at 9 centimeters. It will just about stretch to that. So that's at 9 centimeters now. And I'll put the compass point in the end there. And then I'm going to draw an arc that's 9 centimeters away from that point. So everywhere on that arc is 9 centimeters away from the point. And where it meets the vertical line that we just drew is where we're going to make our triangle. So that goes there. And that was 9 centimeters. And this was whatever we figured it out to be in the question. I think we decided it was 7.48 centimeters. In fact, we can check that that works. Yeah, 7.48 looks good for that. Okay, the third construction. So we've got a 6, a 4.5, and a 7.5. Now, we don't know whether these are right angles or not. Well, we do because we worked it out, but so we know the first one is a right angle. But we're going to try and construct this just from the information about the sides. So I'm going to draw the 6 centimeters at the bottom there. 6 centimeters. Then I'm going to get my compass at 7.5 centimeters for the longest side. So the 7.5 centimeters is from the left end here. So I'm going to get my compass point at the end and draw a 7.5 centimeter arc. So I don't know where the vertex of the triangle has got to go, but I know it's somewhere on that arc, because everywhere on that arc is 7.5 centimeters away from that line. Now I'm going to do a 4.5 centimeter arc, because I know that the other line is 4.5 centimeters away from the right hand end. So I'm going to do a 4.5 centimeter arc there. So where they meet is 4.5 centimeters from the right, because it's on that arc, and it's also 7.5 centimeters from the left hand side of the 6 centimeter line, because it's on that arc. So we've got 7.5 and 4.5 centimeters there. And it certainly looks like a right angle, so it confirms what we worked out in the question, that it should be a right angle. There it is. Okay, and then the very last one, similar sort of construction. We're just going to use the information about the side lengths only. So the base is going to be 5.5. There's 5.5. It's going to be 6.5 centimeters from the left-hand end. So I'll get my compass at 6.5 centimeters and draw an arc there. So everywhere on that arc is 6.5 centimeters away from there. And then it's going to be 2.5 centimeters away from the right end. So I'll get my compass at 2.5 centimeters and draw an arc. Oops, 2.5 centimeters